How well do you know your rules of logarithms? So many students confuse their rules of logs with their rules of indices in this question, and in fact many students left part C blank entirely. In their report after the exams, the examiner said that this topic continues to be one which candidates struggle with, and in all parts of the question. It was not uncommon to see candidates attempting to use rules of indices rather than logarithms. Part C was the most challenging part of this question, and clearly identified the stronger mathematicians of the cohort. Many responses to this part were blank, whilst the more able candidates provided very succinct solutions. This further demonstrated the lack of logarithmic fluency for a number of candidates. Oh dear, let's make sure it doesn't happen to you this summer. We're given log to the base 2 of x is a, and b is log to the same base 2, but of x plus 8. It says express in terms of a and or b, in part A, log to the base 2 of the square root of x for 1 mark. Well, we can rewrite the square root of x as a power of x. Why would we do that? Well, there's a rule of logs that says that we can take this power and bring it to the front. So it appears here and then it disappears from the power here. And so we've got half of log to the base 2 of x. Where have we seen that part before? Well, that's just a. So it's half of a. There you go, you've got your mark. Part B. Now we're to do something similar with log to the base 2 of x squared plus 8x. So we're going to try and find x and x plus 8 kind of hidden here. How can we do that? Well, you notice that these have got a factor of x in common. So we can take that out as a common factor. And then we can use another rule of logs that says that when we are multiplying two things within our log argument here, within the bracket, we can split that up into two separate logs. So this log can split up into two separate logs where we are now adding the two logs, not multiplying, adding the two logs of the two things that were being multiplied within the argument, within the bracket. So you can see how we split that up there. If you do that, you get a method mark. And then you can notice that, well, this part is just a. That's what we had here. And this part is just b. That's what we had in the question here. So we end up with a plus b, part C. Log to the base 2 of 8 plus 64 over x. Okay, give your answer in simplest form. So again, we're going to try to find the x and the x plus 8 kind of hidden somewhere here. The first thing to do, perhaps, is to make a common denominator. So think of the 8 as 8 over 1, and then make a common denominator of x by multiplying numerator and denominator by x, and then combine them together. So we'll end up with 8x plus 64 all over x. That gets you your first mark here. Next, we can look at this part and notice that 8 and 64 are both in the 8 times table. So we can factor out an 8 as follows. Next, we can use a couple of laws of logs. One, the same law as before, that when we multiply the 8 and the x plus 8, we can split that up into two separate logs that are being added. Log base 2 of the 8 plus log base 2 of the x plus 8. So the multiply that was between these brackets here has turned into a plus here. Now we can use a second law of logs that says that when we divide by x, here, when we're dividing, that divide can become a subtraction of another log of what we're dividing by. So that's log of the x here. How is that helpful? Well, hopefully you can spot that this part is just b, and this part here is just a. What about log to the base 2 of 8? Well, that's just a number. It's really asking us a question. It's saying 2 to the power of what number gives us 8? Well, it's 3. So the answer is 3. Log to the base 2 of 8 equals 3. So that's the way that we can simplify this for our final mark.